This video answers some more frequently asked questions about tests of significance. How can your decision be wrong? Well, you're going to make a decision about whether you reject the null hypothesis or fail to reject it. And when you make that decision, there are consequences. If the null hypothesis is false and you reject it, you're doing the right thing. If the null hypothesis is true and you fail to reject it, then you're doing the right thing. Congratulations. In those two situations, you're doing the right thing. Now, here's where you can go wrong. If the null hypothesis is true and you reject it anyway, then you're making what we call a type 1 error. Okay? Even though H naught is true, by some random chance, your sample results in a low p-value and leads you to reject the null hypothesis anyway. That's purely due to the random chance of your sample. Okay, the probability of this happening is exactly the same as whatever alpha level you chose. If you chose a 5% alpha level, 0.05, then 5% of the time, by random chance, your sample is going to result in a p-value that is less than your alpha level, and you're going to reject the null hypothesis, even when it's true. If you want to reduce that probability of this type 1 error, choose a lower alpha level, say 0.01 instead of 0.05. This will make it harder for you to reject the null hypothesis, just by random chance. Now, here's another way you can go wrong. If the null hypothesis is false and you fail to reject it, then you're making a type 2 error. Even though the null hypothesis is false, by random chance your sample results in a high p-value and leads you to fail to reject the null hypothesis anyway. The probability of this happening can be calculated. The calculation is not simple. We'll look at that later on. But if you want to reduce the probability of a type 2 error of this type, you can choose a higher alpha level. Say if you were using 0.01 and you want to make it harder to commit a type 2 error, raise your alpha level to 0.05. Now you notice that when you do that, you're going to have to pay at the other end in terms of type 1 errors. So here's a trade-off you're going to have to deal with. When I choose my alpha level, do I have to face this trade-off between type 1 and type 2 errors? And the answer is yes, other things equal, you do. If you choose a lower alpha level, that'll reduce the likelihood of a type 1 error because it'll make it harder for you to reject the null hypothesis. But it's also going to increase the likelihood of a type 2 error because false null hypotheses are not going to get rejected. And so because of that, you reduce the likelihood of a type 1 error, but you increase the likelihood of the type 2 error. Now, if you choose a higher alpha level, that'll have the opposite effect. It'll make it easier for you to reject the null hypothesis, whether it's true or false. And that's going to increase the probability of a type 1 error, reduce the probability of a type 2 error. Okay, so when you choose your alpha level, you have to consider these potential consequences of an incorrect decision. And you have to decide, okay, what's going to happen if I commit a type 1 error? What would the consequence of that be, practically speaking? If I commit a type 2 error, what would be the practical consequence of that? In some situations, it has to do with, perhaps a monetary award in a lawsuit or something like that. In a criminal case, type 1 and type 2 errors have consequences for the individuals who are on trial as well as for the larger society. So we have to decide which is the worst kind of error in any particular case and choose the alpha level that's appropriate. If the type 1 error is worse, choose the lower alpha level. If the type 2 error is worse, choose the higher alpha level. But that's the trade-off you're faced with, other things equal. Now, most people hate trade-offs, and if you're like most people, you might wonder, isn't there some way to reduce the likelihood of both types of error at the same time? And the answer to that question is yes. And the way to do it is to increase your sample size. Or if you're using treatment groups in an experiment, make those groups bigger. That'll allow you to choose both a lower alpha level to reduce the probability of a type 1 error, and at the same time you can reduce the probability of a type 2 error. So you can get the best of both worlds. A low alpha level, which allows you to limit the probability of type 1 errors, and also reduce the probability of type 2 errors. So large sample sizes are very beneficial. However, they're costly, and you need to be aware of that trade-off between the cost of a sample and the benefits of a larger sample. So In statistics, you're going to be faced with trade-offs all the time, but this is the best game in town if you can afford it, to reduce the probability of both types of error by making your sample size bigger.